Now let's talk about the first application of R in IR, survey research. R can help create a professional-looking survey report. Here is a partial survey report example I created. It has an executive summary and the institutional logo at the center. If you'd like to adapt this look of a report, I've provided a template for you here. You may ask ChatGPT for a detailed explanation of each line of code. Here, I just want to provide a high-level introduction. The top group of codes tells us to generate a PDF using PDF LaTeX and defines the formatting for the document, the overall figured length, and the page margins. The next group of codes specifies the headers, content, and formatting. This is also where you will change the logo to create reports for your institution. Please note that these codes are not typical R code. They are YAML header codes. You'll usually find them at the beginning of an R Markdown file, which is used to customize the output formats. Now, let's move on to another important component of a survey report, visualization. In this case, I created a scatter plot to illustrate the percentage of agreement for each survey question among all respondents, and also segmented it by their class level. Let's walk through the codes used to generate this visualization. Firstly, we create tables, similar to pivot tables, where we will use that later to transform it into a graph. The tables we created here are overall table and class table. The overall table calculates the percentage of students' agreement for each survey item. Class table, on the other hand, shows the percentage by class level. Next, we merge these two tables to display all the data in one table. Additionally, we defined the order of survey questions based on the overall percentage of agreement. Now we're ready to develop the visualization. We use ggplot2 and geom_point to create a scatter plot. We set the y-axis to be the ordered survey questions and x-axis to be the agreement percentage. We also made some customizations to enhance the appearance of the plot. The benefit of writing codes for visualization is that it allows easily replication for future plots. Simply copy the codes and make adjustment as needed. Let's pause again here to see if you have any questions. Before we proceed to the next application of R in IR, it's essential to address the data cleaning process that comes before our survey analysis and visualization. Let's use the same survey data we used in the previous section as an example. When we export the survey data response from Qualtrics or other survey softwares, we only have a raw data set, which contains several columns that we need to exclude. We also need to clean names, remove duplications, and exclude NA rows or columns. You may learn other ways to remove NA values, such as complete cases or NA omit function. The method I used here is what I preferred, as the column and row sums can get to a bit more specific of what we are doing. After performing basic cleaning, I proceeded to rename and recode data values. For example, each survey question is renamed to agr.sec, followed by a brief summary of the question. This makes it easy to identify the question's corresponding assessment section by just looking at its name. We also recoded to simplify the categories of survey answers with a binary survey answers of yes or no, we can show the percentage of students who answered yes, instead of having to show all the 4 categories of answers. However, it's important to note that this simplification may have consequences for regression analysis, and the original 4 levels may be better for a more detailed analysis, such as regression. Additionally, I replaced the survey option N/A with the actual NA values for R to correctly recognize it as NA value, and we can later exclude them during our analysis later. The last line of code is a check that these cleaning processes achieve the desired outcome. It's beneficial to develop similar checking codes at the end of each step before moving to the next one. Now that we have a relatively clean data, we may start to brainstorm the analytical plan. We may ask ourselves, besides survey answers, what other variables can provide insights into the assessment results? One helpful exploration is to link survey respondents to our administrative data that contains student characteristics. For example, class level is an important variable to include in our data visualization that we showed in our previous section. To accomplish this, we first load our student enrollment data and performed a left join to get a comprehensive data set. Last but not least, I found it beneficial to transform the data set into a long format. In the original data set, each column represented a survey question, and each row represented a student's all survey answers or their characteristics. After the transformation, we get a longer data set. Each student now has multiple rows, with each row representing their answers to a different survey question. This transformation allows us to summarize all the survey questions at once, since the survey questions are now in the same column. So that concludes our data cleaning process. However, for documentation purpose, it's recommended to save all process files into an Excel file. This keeps a record of our data cleaning steps and can be referred back if anything needs to be adjusted. Let's pause here to address any clarifying questions. Now I'd like to briefly share how regression can extend the survey analysis. I employed the plur function to perform an ordinal logistic regression, and then selected an optimal model using STEP AIC. The model describes the relationship between technology competency that we assessed in the survey, and that's our dependent variable, and other independent variables that are skills assessed in the survey or from the administrative data set about students' characteristics. After calculating the p-value and odds ratio, I uncovered intriguing connections and distinctions of our finding that aligns with existing literature. This survey project holds potential for future publication. Throughout the entire survey project, R has been instrumental in assisting me with data cleaning, visualization, and regression analysis, and generating comprehensive reports or publications. Now I invite any questions regarding the content about survey research we covered